Assalamualaikum and very good day for all of you. Today we will continue about angular speed measurement. What is angular speed measurement? It's just how it measure the speed of the motor rotation. Motor rotation. Later on we will discuss. But for this one, the disadvantage of this chapter is it is impossible for us to run by using simulation 100%. You must have the hardware in order for us to measure, to test either the coding is function or not. So today I will just go through the coding and some basic on the angular speed measurement, and I will share with you guys in ulearn any video how they run the real hardware to measure the angular speed of the motor. Alright, now let's start. So the learning outcome, we will understand the concept of angular speed measurement in terms of hardware, and then we understand the concept by using hardware and software. This one we will use software interrupt. Interrupt we have learned previous week, alright? Okay, the introduction, angular speed or velocity simply refer to how quick an object is rotating. Actually, this one to measure the motor motor speed. You don't consider motor is a 125Z and so on. Motor is just a motor. For example, you have engine Tamiya, that one the Tamiya dash yang kuro and so on. They say they have the motor there, DC motor, any type of motor. Usually, positive indicate the counterclockwise, while negative is clockwise. Okay, you know how to measure counter or where you want to check from the front or the back of the motor. Actually, to check it, you need to go from this one. Okay, this is the motor. Here is the front. Here is the back. You check from the front. This is your eye here. You check from here. Here is counterclockwise. No. Right is clockwise and turning left is counterclockwise. This is how for you to measure rotation of the motor, right? Okay. And then what unit they have? For this one, motor speed, usually they have hertz, radian of second, but most of the time we are using this RPM, revolution per minute. If you drive a car, you will have the RPM, right? RPM, that one is revolution per minute. That means how the piston is moving in 1 minute. Very fast, that one. Okay. In microcontroller based application, angular velocity is usually measured in RPM, right? I say most of them we are using RPM. Example of the application is we read the DC motor speed, turbine speed, or gear speed. This is the application of this angular velocity lah. Alright. The measurement is done by using encoder disc with optical sensor to connect interrupt. Okay, later on we go to the sensor. Actually, we will have one sensor and then you will keep cutting that connection sensor so that it functions. Later on we will have this kind of slide. Hardware and software interrupt will be used together to measure the speed. Alright, this is how it functions. This is the motor, DC motor, and here we have this. You must have this kind of encoder disc so that this we zoom the speed the disc. Actually, in the disc we have some open area here, and then you will have photosensor, LED and photosensor. This one will transmit, this one to receive, and then every time they go to the hole here, photosensor will detect an input from LED. But if they not going to the whole area, the lubang here, this one will not detect any light from LED. Then this is how they measure. When they rotate, they will have on, off, on, off, on, off. Then this you will obtain this kind of sensor, this kind of input from the photosensor. You will have the rising, falling. Rising here where they have the light. And then suddenly you block the light by this area. Then they turn off. And it keep rotating depend on the speed. If the motor rotating slower, the signal here will be larger or smaller. will be larger. Because it have longer period to turn on, longer period to turn off, then they will be larger lah. Alright, this is how the theory, how it measure, how they want to measure the speed. Okay, this is most of the current motor. This one a little bit expensive lah. There are motor DC motor that with built-in encoder. For example, this one they have photo sensor already here. So when you run, very simple, you keep running, very easy. And then you can see here, it's not connect at the front of the motor. This is connecting at the back of the motor. At the back of the motor. And then here we'll have the load here. Okay. Same goes to here. Here's the back of the motor, here the rotating of the motor. Here the back of the motor, they have here and so on. Alright, how to measure, how to calculate the angular speed? A, this is the formula. A divided by xt multiply with 60. A represents the counted hole in period of t. That means you measure, let's say you want to measure 10 seconds. How many hole you measure from the photoresistor? And then here, total holes, X here, total hole in the disc. For example, you buy the disc with 60 hole, then just direct 60. Interrupt periods in second. What's the interrupt period? This one already set up by your own. That means you set up. And then last you multiply with 60. Why multiply with 60? Because this one revolution per minute. And then this one interrupt period in second. That means this one is second. You multiply with 60, you will have minutes. Okay. Now we have this one circuit. This is how the circuit calculation. Power adapter, just connect power. In this one motor driver, just to turn on the motor. We have here this one. We supply digital, whatever. This one all connection set up already. And then this is the sensor, optical sensor module. You just connect it. Go to the input number 2, and then you just measure the motor. How motor rotating, and then you will measure on and close. This is the coding. Okay. We go through line by line here. So here float timer 1. This one for what? Interrupt. Timer1.h interrupt library. Float rotation, float runner counter, just declaration. Integer number of holes. This one 48 mean number of holes inside of this blade. Alright. Float interrupt period. How many interrupt periods? 0.1 millisecond. 0.1 second, sorry, 100 millisecond. And then just declare integer pin number 3 for C3 for enable B. This one come from this motor driver. In 3, in 4 enable B. And then connected to pin 765. 765. Pin interrupt 2. Okay, this one. Why pin 2? Because you connect this optical sensor into pin 2. Okay. Next, motor speed 150. Okay, why 150? The max, because you connect this motor to PWM. You know PWM maximum is 255. 150 means you are now running 150 out of 255. So let's say you divide by your own lah. If you want to run at the half of the speed, you put here 126. Alright. If you put 128, sorry. If you put 128, that means you are running at the half of the full speed. Okay, now we go to the void count. Just a declaration of function, counter plus plus. Void time ISR, again, this is a function. Rotation equal to counter divided by number of all multiplied with interrupt period times 60. This one comes from the formula that we have measured previously. We have learned previous slide. And then counter equal to 0. This one just to reset again the counter here.